Okay, so we're back here. Now, yesterday we went and worked on the flash of the nuclear blast. It's of course going to be end up turning into the flashbang explosive as well when we eventually get that coordinated and working a little better. There is a few minor issues that I did discover with it after finishing up the recording. The angle math is not quite right. We're not going to really worry about that because we know it does work. It just doesn't work perfectly. It's something I can flush out as I debug and work on stuff. Now, that's only one part of the nuclear blast after all. One of the other parts I ended up figuring out that was a major issue is the thermal blast, as I've noted a couple times, is not working quite right. I actually sat there and watched one go off for a while and ended up with a 400-meter lava pit. I have changed it so that way stone materials cannot be turned into lava anymore. This actually will help with TPS and FPS as well on servers. It does turn them into cobblestone now. This is not exactly what we want, but we're not at a state yet where we can kind of work on that. The plan is to do what I'm working out here with this code right here, is to do a proper thermal system of using real life actual mathematics to figure out what we actually need to turn things in. I have been toying with this. This code does sort of work. It will figure out how much energy I need. From that energy value, I can then go, okay, this blast only produces, say, 1 gigajoules of energy, and then that's how much you have available to melt items nearby. I still have a lot of physics to do, and I have to figure out how much heat I can transfer into a block before that block is capacitated and destroyed. There's things I've got to do with this mathematics. For example, I've got to figure out how much energy it's going to take to just heat the block up, how much energy it's going to take to melt it, turn it to a gas, and even a plasma, as we're going to get hot enough at the center of a nuclear blast to turn some stuff into plasmas. This is a lot of physics I will have to apply. A lot of it's probably going to be partially faked because we just can't do this much mathematics on the CPU and still have the game function quickly. So it is very likely that we will just cache a lot of this and we'll go, okay, we're reasonably within the amount of energy we need to melt this, and we'll just melt it. A lot of this as well is the heat's is going to be dumped into the heat map. The heat map is unfinished. I thought I actually did finish this a while ago, but I was mistaken. What I was thinking of is that in 1.6.4 we did have a heat map that was pretty primitive, but the new version is not implemented yet. What the heat map will be used for is, in case it's not obvious, is it'll store the heat per tile, and with that we'll be able to determine if blocks should melt. And this will let you also do cool things. So say for example your bunker is very vulnerable to heat. Now a bunker that's meant to survive a nuke actually will not survive direct contact with plasma. But what you could do is line your bunker in something like aluminum, which would capacitate heat very well, and in between layers of aluminum you could put water, because water acts as an amazing heat capacitor. It will store a lot of heat before it actually turns into steam. I think it takes somewhere about 6 million joules of energy to take 1 kilogram of water and heat it up. Now, of course, a liter of, or a meter cubed of water in Minecraft would probably take a lot more than that. We could do the math. After all, I do have some of the math opened up over here. Really simple equation. Specific heat, mass, delta change, although I do have to do a lot of other stuff here. This is me trying to figure out how much I need to heat up things like copper and aluminum. There's a data table for this, so it's not like I have to do much work, actually. It's already listed out. Some of the more things I'm trying to go find out is some of the... there is an actual list of energy values per state of matter. So when you go to heat something up, you don't just apply constant heat and then it changes into the state. There is actually a point when it, say for example, goes from a solid to a liquid, there is an extra energy amount that you have to input to break the state system. This is the reason why water takes so much energy to heat up, because it actually only takes a couple million to heat up to a gas, but then it takes like 2 million to actually go from a gas, or go from a liquid to gas, additional to that. This is actually calculated down with these equations right here. You need 2,600 joules per gram of water. And that's, of course, times by the mass. And then let me get figure this out. Mass of water by volume. See if I can find a really quick calculator for this. So water, I think everything's scaled against water anyways. The density of water is 1 gram per cubic centimeter. So all we need to do is go cubic, if I can spell, cubic meter to centimeter, or cubic centimeter. So of course we want to put in 1, which is going to be this value. That means a block of water is 1,000 kilograms. That means it is going to take an insane amount of energy, if we can actually do the calculations here. That's what, 1 million times 4.186. That's just to heat it up 1 Celsius. So say we wanted to actually bring it to boiling point. That's 167 million joules of energy to heat up that single block of water. And then if you add to the fact you got to do this as well, additional to that, which and there's a memory store here, memory store, and then we can do that 1 million times 2600. So that's thousands, millions, 2.6 billion joules of energy to heat up a single meter of water. Now my math might be slightly off on this. I want to say that this is maybe not quite correct. It potentially is. It takes a lot of energy to heat stuff up. And this is going to be directly reflected by a lot of this stuff. This means some of the explosives are probably going to get a little weaker because I'm going to start implementing realistic energy values for a lot of them. But the trade-off for them getting a little weaker when it comes to their destructive capabilities, they're going to have a lot of weird quirks and characteristics that will end up making the damage still level out to where they were. For example, a lot of the explosives are going to get shockwaves on them. Shockwaves will knock out glass, take out power lines, catch trees on fire. Shrapnel will be increased, so almost every explosive that actually has a blast, so has something that goes boom in the middle, will have shrapnel. Shrapnel is highly deadly. Take, for example, a standard hand grenade used by the US Army has a lethal range of 100 meters. If you're within 100 meters of that grenade, a piece of shrapnel could hit you in the head and kill you. That's just how powerful it is. Video games don't quite get it right. Video games are like, you have to be within like 3 meters of the grenade to take damage. That's from the concussion wave. Now the concussion wave is pretty small, but the shrapnel is what actually would end up killing you half the time. Especially from bullets and stuff. Bullets can actually shrapnel on impact of things, and you can get hit by a piece of shrapnel which can mess you up. Take, for example, my dad, he's got shrapnel in his leg, as well as had shrapnel dug out of him when he was in the military as well. So, and he wasn't even in a war, he was just doing guard duty. So, well, at least that's what he tells me. The reality of it is probably different. So we're going to ignore this though, because this is something I'm going to have to work on my own. This is going to take me probably, if I was to record every moment of me working on it, it would probably be a dozen or 2 dozen videos because it's a lot of work. I have to implement energy values. I have to actually implement this. There's literally nothing in the heat map. That's the reason why I said it's not even done. Mass registry isn't done, so there literally is no logging for mass at the moment, really. I need to implement JSON handlers for this, so I don't want to input this data by hand in the code. What I want to do is go get a JSON file and go, okay, here's every block in Minecraft, here's exactly how much it weighs, here's what materials it's made out of, here's how much energy it takes to heat up, here's how much energy it takes to melt, here's what happens when it heats up to a certain point. For example, woods would just catch on fire. That's what you would do with wood. And then you would vaporize things like leaves. Leaves would just disintegrate because they're so low in mass, they're actually so low in density actually, that there would not be much left. They would just heat up and vaporize. That's something that would have to be handled by this exothermic thing, but right now I'm going to go ahead and launch this. I'm going to show you that the cobblestone now works the way it does. There is plans to modify this, so the idea right now is I'm not going to turn anything into a liquid anymore because it's too laggy. This may change in the future if I can program some liquids that behave a lot better, and if I program the liquids, I'm going to multi-thread them. So what you'll do is you'll have a block in the world. This will then register itself to some kind of registry going, I'm a fluid, and then there will be something like the heat map that would slowly balance the fluid in the world and update the world accordingly. It'll work like Terraria. If you guys are familiar with Terraria, it has a secondary program thing that actually runs to update fluids in the world. The fluids are not updated in real time with the game. I don't know if it's threaded. That's the reason why I haven't said it's threaded. It could still be running in the main game loop, but it's not. Your fluids aren't individually updating. They're actually handled in a separate layer on the rest of the map. And I kind of want to do the same thing with Minecraft here eventually. I even want to make the water work that way, because if I can make water work that way, we could do some really cool water physics. We're talking like things like you can start draining oceans, caves could fill with water, make water parks. Water parks would be fun. Imagine making a slide and water actually flowing down the slide. And if you turn the water off, the slide then drains of all the water. Same thing for lava. We could actually do proper volcanic eruptions too with lava if we could run an auxiliary fluid system. Because right now the in-game logic in Minecraft, we cannot rely on block ticks for that because their block ticks are really inefficient. They are worse than Tilinity loop updates. So Tilinities run every single tick. Block updates don't necessarily run every single tick, but usually they're a little bit more resource intensive because you can't cache values. So you're using a lot more CPU. This is the reason why grass surprisingly can end up taking up 3 or 4% of your CPU on your server if it's spreading a lot. I actually have a mod that has multi-threaded grass in it, and I've actually noticed some pretty good significant server performance gains out of having it multi-threaded. I plan to actually do a lot of work with that down the road. It's going to be a while though, so don't expect that mod to be released anytime soon. After all, it's taken me a couple years just to update the 1.8 and I'm still not finished. This is where I actually badly need more developers. Actually, some of the biggest things I actually need right now is I need people to go work on the wikis. We don't have any documentation when it really comes to how to play the mods. This is actually hurting the download rates of the mods because people don't know how to use the mods and therefore they're unwilling to download the mod because they'll go and they'll find a tutorial and like, oh, this is the 1.6.4 version of ICBM and they can't find a tutorial for the 1.7.10. Although I do know a couple people have made tutorials for it now, which is I think has been helping the download rates a lot more. I need to go get somebody like Yogscast or Direwolf to go do the new version of the mod. Although I probably have to update it to 1.10 for him to do that. Okay, you can see a crater right now. This is basically cobblestone out for probably 400 meters. Yeah, it goes on and on and on and on and on forever. So anything that is marked as stone will get turned into cobblestone. I'll probably take cobblestone, turn it into gravel. I'll probably take gravel, turn it into sand. This is just going to be a layman's indication that heat has been exposed to it. I'm going to make a lot more blocks to better reflect this because what I'm kind of trying to express with the cobblestone is that it's heat cracked the stone. If you've ever heated a stone up before, they will crack. Don't do this with sandstone, it will explode and it can really harm you. So do not do this, do not do any of that at home, it's really stupid. I have actually been shrapnelled by sandstone before because somebody decided to make a fireplace out of it. And again, this is the same person that decided to burn poison ivy and somebody got almost died from that. Don't burn poison ivy. If you ever go camping, don't burn anything unless you can identify it because some of that stuff that looks like really strange weeds is actually can be toxic plants. Poison ivy is not the only plant that when burned can be inhaled and can kill somebody. But anyways, you can see already it's starting to break up the cobblestone. It'll actually spread out for quite a while. The radius is a little high. I'm going to drop the radius down to be only 30% larger than the actual blast itself. That way it's not as intensive. I've also been talking to a few of my other devs about potentially breaking up the blast into multiple threads. What I've noticed is when this does run, it does take a while to run the full radius. An ideal is to split this into a quarter, so that way we're running each of the quarter on a separate thread, that way it runs even faster, or even break it into eighths, although breaking into eighths is going to take a lot more code, and quarters is easier to do because what I can do is just do an axis of plane and go, if you're plus x, then this is thread 0, that's thread 1, this will be thread 2, and that'd be thread 3. It's really easy to do math like that. And it won't mess with the pathfinders. The pathfinders work really, really well, and all you have to do is say, okay, I have X amount of energy to expenditure that way, and then you can make the threads call back to a central object going, okay, I hit a wall here and I can't go forward. Here, I'm going to give all three of you the rest of my energy. There's a lot of stuff we can do with that. EMP in particular is something I'm probably going to actually multi-thread more. It's because the EMP radius is about 500 all around this blast. I'm also going to probably do a micro EMP right before I run the main nuclear blast because I need to EMP force fields before this goes off. So the force field will weaken. There's a lot of things I got to really work on because, as I've noted in the previous videos, real nukes are not linear. They're you can think of them like they're multi-threaded. Everything runs simultaneous and they're asynchronous. They just kind of run. They just do the damage and they go out in all directions and etc. etc. Okay, so now that you've seen all this, we're going to get back into it. Now, we're going to just do radiation real quick. Radiation is not something that's going to take too much work. What we're going to do first is we're going to do the instantaneous radiation, and then if I have time, because I do have to leave here in about an hour, I got to go help set up for my cousin's graduation. She just graduated from high school, and needless to say, people are throwing a party. By people, I'm talking my grandmother. She throws a party for everybody. It's probably about the only social interaction she gets, unfortunately. I wish I had more time to go spend doing stuff with her. So this is going to be a potion. So what we're going to do is we're going to make another blast. Probably just want to prefab this out, actually. Trying to think of like the best way to handle this. Because what we can do is instead of... Nah, I'll come back with this. What we'll do later is I'll make a JSON system that's designed for the potion effects, because these are all the same. These are like, okay, if the person is within distance, and then you can also make a JSON really easily handle that they have to be staring at the radius. What we'll go ahead and do is we're going to clone these two. Shoot, it won't let me clone both of them. So we're going to call this EX. I think, actually, you know what? I think I already have a... Yeah, we'll do that. We're going to drag this down here. The reason why we're going to do this as a potion effect is I want to make sure to recycle these blasts as much as possible. The more you can recycle your code, the less work you have to do. And as I'm already having trouble keeping up with updates as it is, I want to get in a state where I'm doing a lot less work. That way I can build a lot more content. So this needs to be blast radiation. This is only used for return calls. It's a generic there. And the only thing we got to do is change this right here. So, and then we want to change this angle here. So we do want to check distance. And we want to modify our radiation level by distance. Now when it comes to the radiation, I want to say if you're behind a shielded wall, that you're fine. I don't know exactly how to do this though. What we'll do for the moment is we're just going to run a ray trace directly from the center of the blast to the entity, and then if it can see the entity, we're going to hit them with radiation, and then I'm going to come back through here. I'm going to have to write a custom ray tracer that will ray trace and will only stop if it hits certain blocks, and this is if we actually follow through all this. We would have to copy this ray trace here, which is a bit of a lengthy thing. It's not too complicated. This is actually pretty simplistic. It grabs collidable blocks, and then what it does is it goes, okay, if you hit it, what we would simply do in here is we would go, okay, can I go through the block? And if the answer is true, you would just ignore this on the ray trace hit. But I don't want to spend a huge amount of time in this video doing that, because if this goes wrong in like any particular way, it could be hours of me toying with it just to get it to work. And right now we don't have any radiation-proof materials. The closest things would be metals, so iron would definitely slow it down. Concrete walls would slow it down by like 10% or something, because what we're doing is we're mimicking neutrons. When a neutron hits a person, it will really screw that person up. It's what destroys your DNA. It's one of the many things that does, at least ionizing radiation and everything. I'll probably research that more, and I'll actually give you guys some information on it later. But what I do know is that a nuclear blast, when it does go off, it produces a lot of ionizing radiation. It produces a lot of neutrons that fly out. I know the neutrons, for a fact, when they do hit you, will hurt pretty bad. It's one of the reasons Reika's reactors does the same thing. When a neutron hits you, I think his instantly kills you, though. I'm going to do it where it's going to mess with your DNA on your character, and it's going to apply negative effects, and your character can get cancer from this. Your character can get severe effects, like you can get severe radiation poisoning, and your character not only will die slowly, or it could die instantaneously if you're too close. That's actually one of the things we want to do. So we want to go, okay, if you're within distance, and we want to go, okay, if distance is less than size times 0.3, we're just going to apply a severe amount of damage. So this will be to do lethal. I don't know how to spell lethal. I think it's spelled like, no, it's not spelled like that. We're gonna do this. Lethal. I didn't say weasel.
According to Wikipedia, a weasel
Weasel.
is a mammal of the genus Mustela of the family Mustelidae.
Oh my god, Google. Well, it at least showed us how to spell it, though. Sorta. Okay, so we'll go 30% of that is going to be lethal radiation. Actually, no, we're going to drop this down even more. We'll say 10% because you got to imagine that these are going to be scaled to a certain size. Then we're going to go, okay, if you're within 50%, heavy damage, and then anything else is like light damage. And we don't have a radiation effect right now, and we're going to need a thread to kind of handle this. So right now we're just going to apply a wither effect. Yeah, we'll go here, grab this. And I believe wither is just one of the registered ones. Yep. That's weakness. No, weakness works. We'll do that, and then we'll copy it again, and we'll get the withering effect. Wither might not be one of the ones that's actually registered. I guess it is. Oh. I want to see what level this is. That is maximum on this. There we go. Okay, so Wither Skeleton does 1 to you by default. I don't know if there's higher level Withers. So we're going to just, we'll leave it at that. And then what we'll do is we'll set it to be 2000 for both of these. And then we're going to copy this down. And then we're going to leave this as just, we'll leave this weakness. So this will be weakness 1. We'll change this to 1. We're going to change this to 800 ticks. And then this will be 200 ticks. And that'll work. It'll give us some testability here. We don't need anything fancy. We just need to be able to test things. And then I need to make an EX for it because you can't actually trigger these without it having a handler for them. So this will be EX radiation. And then, yeah, we're just going to call it radiation. We're not going to be special with our names. We're just going to be like, yeah, that's just what it's called. And this will be Control F, no, Control R to replace, and blast radiation. I don't know why they didn't replace all for some reason. Okay, so that'll work. And then we just got to register like we did yesterday. And eventually this will also be registered via JSON for those who are asking why I'm doing it the old way still. I haven't implemented the loaders for it, and there's not a lot of point at the moment to do a lot of extra work for not a lot of reward. There we go, get that registered. And then we got to register that in the main thread, or main loader. And we're good there. So that'll give us radiation access on that. And we're going to copy this, and we need to go over to the nuke, and we need to, of course, copy this so we can add another radiation thing to this. Now the radiation on this is going to be pretty short range. So this one's only going to be twice the radius. Actually, we'll do 4 times. That's 20. I'm going to drop exothermic to twice because it's pretty large radius as it is. Actually, what did I say? Was it 30%? So we want to do 1.3. I'm going to do EMP as 5 times. We're going to do flash as 4. And then radiation is 4. I'll play with the flash a bit more here. Because the idea behind the flash is if you're staring at a nuke when it goes off, even if you're well within the safe radius where you're not going to get irradiated, you're not going to get any like key exposure or anything, you can still be blinded. This has been well documented because they've had, during nuclear tests, when they were testing things, they've had people be a little too close when they were looking at them, and, well, needless to say, there's some blind people in this world because of nukes. As well, they do have well documented of the 2 nukes they dropped on Japan and a lot of the survivors, so they know kind of exactly what has happened to people. Not to mention, people who've been exposed to radiation and etc. from working on nuclear reactors and things like that when they were not supposed to do things and they fucked up. You know what, probably here next week we're going to probably work on atomic science if we get the nuke done, because I need to get the nuclear material to start making these, and then I need to add a radiation suit. And then in the armory mod, I will add a combat version of the radiation suit, including several different levels of it, and if I can get my modeler to do things, we'll make some nice models for them, and I kind of want to do some Fallout style power armor as well. That way I can start prototyping the modular power armor type stuff that I want to do. Not to say I'm going to clone modular power suits, because even though I like that mod, I want to get down into the details of kind of how I want to build stuff up. Modular power armor, I believe, lets you put whatever you want onto the armor. I want to be more restrictive with it. I want to start playing into the ideal that there's a lot more power management into the ideal, and I kind of want to lean a little closer to how Factorio does their power armor, to be honest, as well, but I haven't figured it out quite yet. I know for sure I want to do some, because I want to do really nice combat armor. I want to do things like you can have a sentry gun on your back, a variety of jetpacks, wingsuits, different ways to generate power, different defensive systems, a lot of magic integration. Even though I'm building technology mods, I want to integrate with as many magic mods as possible, because people do enjoy magic mods. And to be honest, I enjoy things like Thaumcraft. Thaumcraft is still one of my more favorite magic mods. Not too much of a fan of Botania, though, or Magic Crops. I find the both of them a little unbalanced. But that's Magic for you. Magic's not really designed to be balanced. It's meant to be more fun. I'm currently playing on a server that's got crop 6 on it too, and I'm having a little bit of a bad time trying to get resources because I'm not accustomed to farming. Even though the irony of it is that I actually know how to farm rather well in real life, except in video games it's a little different. The main problem is getting automation up. We're having a lot of power problems. Trying to power things off of, well, we were trying to use forestry, then we found out forestry, or not forestry, yeah, no, it might have been forestry. We found out forestry's machines are really FPS intensive, and it doesn't make any sense because their machines are not exactly high renders. Anyways, let's mess with these cows. Now we should see these guys get withering effect and weakness. I should get it as well because I'm close enough. Yep, withering effect, weakness. Of course they're gonna die from the fire. Actually those guys just got hit by the withering effect. Yep. That'll be our pseudo radiation for the moment, so that's pretty good. What do we want to work on next? Because I don't want to do the radiation particles right now. Well, shrapnel maybe. We need to throw up debris in all directions because we need to really mess with the terrain here. I need to kick this dirt up. I want to see the dirt disappear like out in the distance here. Too much dirt left alive from that explosion. Because stone, it makes sense for the stone to kind of exist after a nuclear explosion, because the stone you gotta imagine the stone would be like bedrock. It's really tough. It's really hard. And I'm talking about bedrock in real life, not bedrock in Minecraft, because Minecraft's bedrock is not what real life bedrock is. Real life bedrock is just really, really tough stone that we have trouble drilling through, and usually is the bottom of where we mine at. You can mine through bedrock. It's just a pain in the butt. Usually they use explosives to do it. But that's good. I'm gonna say we probably have cobblestone going out for days. Yeah, I need another explosive real quick. We could build a force field here and actually test to see what the nuke does to the force field, but I'll do that another day. I'm not too into wanting to do stability testing today on MFS because I know it has problems. Yeah, we got cobblestone going for quite a while. Now, I'm gonna have to make my own fire for this eventually because I want this stuff to decay really quickly. This stuff sticks around a little too long. Okay, so we see our limit here. That's about 20 blocks in there. That's not too bad. It probably goes equally as deep. It's actually kind of cool. What I want to do though is you see how we got gravel ore here from Tinkers. I kind of want to start using gravel ore to replace the ores because right now this actually will delete ores, and I don't want to kind of delete the ores. I want to turn them to molten ore and then have them reharden. I kind of want the stone to reharden as well, so you get it'll be solidified stone is what it'll be, so it'll be a black and charred stone. And I kind of want to get a variety of that going. That might be a while though. There's a lot of those blocks I want to do. I want to do a lot of like burnt soil and stuff to get this nice, elegant, beautiful look when stuff goes off. I gotta open that up. Oh, whatever. Discord's not gonna do anything for me. So we're good there. So yeah, I guess shrapnel is the next thing to do. Now I think it's really simple to do shrapnel. I just have to add an event throw. Because every time we blow a block up, there's an event that's fired, and the shrapnel is produced automatically for anything that will fire a destructive block event. However, because the nuclear blasts are considered non-destructive in the code, they don't produce events properly. Now we can theoretically fix this. Let me take a look at this because okay, radiation's good. We want to take a look at blast nuke, close ex nuke, and I think there is a method that sits in the bottom of this code here. And that just simply asks, are you a destructive blast? The reasoning for the differentiation, by the way, is even though a blast can be destructive, what it's asking for is did I, like, using brute force blow that block up rather than magically teleporting the block around or something. Because you wouldn't want to produce shrapnel if, say, I ender teleported something. You wouldn't want to produce shrapnel if I melted a block. Although having some like little particles fly off when you melt a block would be cool. Surprised this doesn't crash the game when it runs. There's damage entities. Have to work on that. So there's pre-placement here, which allows you to cancel the placement or modify the placement. So say, for example, when I hit a block with a certain blast type, you could decide with this event that you want to change it to, say, mushroom blocks or something, or water. Here's what I think we're looking for, is this right here. Event replace, and there's event remove. So replace is I'm replacing the block with something, and the remove is only fired if we're changing to air. I think these are what we're looking for, but at the same time, it doesn't quite look right. So what we're going to do is we're going to go take a look at the TNT explosion, which is built into the core of mine, or built into the core of Volt Engine. So that would be prefabs, explosion, blast, and that would be blast basic. I don't know why there's even a to-do up here. This has actually been handled. This is how old that is, by the way. I've been working on that for like 3 years. Not quite 3 years. It's been 2.5, but a lot of time when you think about it. So here's on block destroyed by explosive. That's not quite what we're looking for. Here's what we're looking for. There's a separate event fired. So what we want to do is we do want to fire what this is doing right here. Stack instance of I blast, an event instance of blast pre. Why would the event shade? Whatever. There's some reasoning behind this. Yeah, so we're just going to copy these two because this is going to give us exactly what we want. And then yeah, that'll work. Let's go ahead and just launch it up and see how we get. I may have to work on the shrapnel. I may have to reduce the amount of shrapnel that is generated because if you know from just watching that TNT one go off, that causes an FPS spike that's noticeable every time it goes off. That's because we're essentially spawning a whole bunch of entities that fly in the air. I probably work on some graphic settings to fix that. I'll probably additionally see if I can catch the models so they render a little faster. I could use VBOs to do that. It's I need to do that for my fluid renders. It's one of the things I've been noticing when I've been playing Regrowth. I think Forestry has a problem with its fluid renders is what's causing the FPS drop. I honestly don't know. I could spend probably several hours investigating it and then find out it's just absolutely odd. And there's no point in even probably investigating either because I'm not going to get the developer to do any patches. And I'm definitely not patching it myself because in all reality, if I'm going to go through the effort of patching Regrowth, I can go through the same effort to clone the mod pack, replace several of the mods with the most updated versions, and then throw something like MFR in there. Because I like using MFR for farming rather than Forestry, because there's not a huge difference between them. Forestry just has this little bit more complicated machine that requires a little bit more resources than MFR. Then it's just a pain in the butt to farm with. Our forestry farms keep breaking on us, and it's really annoying. And there's no legit reason for them breaking. And of course, we have problems with the mechanism cables. At least I'm pretty confident the reason why the mechanism cables keep breaking is just that version that's in Regrowth is just faulty. And I'm pretty sure Aiden has fixed a lot of those issues already. Because they are related to chunk loading. And if he hasn't fixed them, I might go out of my way to patch mechanism. Actually, by patching, I may just pull request a fix directly into the mechanism repo, and then just ask Aiden to make a new 1.7.10 version release. Because there's enough people that do still play in 1.7.10 that would be highly beneficial to actually fix any bugs in it. Though that being said, I need to spend my time working on my own mods here. Because I want to get basic industries off the ground. I got to go work on my cables in there, and if I guess if I'm going to spend time patching things, I could just go fix my universal cables. Because at least the beauty of my cables will be, so Mechanism has the problem where it doesn't really split power really well between machines. The code I wrote for UE4 before UE kind of died was really, really good at splitting power. It kind of could grasp what machines actually needed power better than other machines. They would attempt to power smaller machines before to power bigger machines. Because logically, your smaller machines are going to be using like 1 or 2 watts of power, are more than likely things like item movers and stuff like that. They're small machines that need to run. What were we implementing again here? We were, oh yeah, fragmentation. I lost track of what I was doing. Getting those little rants there. Actually, would the correct definition be a rant, or would it be... I gotta come up with a better word for that. Oh man. Yeah. Um, oh no, I hit F3. I can see the FPS in the corner because I got Steam running. 1 frames per second. 2 frames per second. Can we get a 3? Yeah, we're gonna need to consider some serious optimizations for this. I'm trying to think of like what we exactly could do. I know I'm saying we can catch the models, but I don't think the models are really the problem. I could batch render them. That actually would help. That would provide some wonky stuff though. The reality of it is I'm just going to have to drop the quantity of particles. It's about the only thing I can think of to actually do to fix this. I want the particles to be thrown out. And actually, let me rephrase, these are not actually particles. These actually are entities that are being thrown through the air. They are projectiles, like arrows pretty much. So they will actually kill things when they hit them, and they'll fuck things up. And oh, wow. Oh, it's starting to die down a little bit here. One thing to make this probably reduce a lot better is to say that we're going to vaporize a certain amount of the particles in the middle. Interestingly, it's doing a pretty good job actually here when you could think about it. But the cool thing about all those particles going out here is it's going to catch things on fire in like all directions. And why am I only seeing particles going like 2 different directions here? Oh, there's some going that way too. Why am I not seeing anything going this way? I feel like this side has been left out. Oh man. Um, we could fake it. We could say instead of blowing up particles per block we're destroying. So how this actually works, I believe it's like a randomizer between like 1 and 10 number of particles it throws out per block. We could decide that we just generate a certain amount of particles just because the blast goes off. I like this possibility a little bit more because it lets us control the distribution a little better. As you notice, we're not getting anything over here, which tells me there's something wrong with the distribution. Then again, there's all kinds of things wrong with the distribution because we got this little diamond shape going on here. Frame rate's not doing too bad. I'm doing 50 considering all the fire. Not bad. One of the things I actually do need to do with a lot of these explosions is I need to start doing force calculations because you see how we got like this 1 block thin wall between this cave wall? Realistically, the blast would have found that weakness, it would have blown clear through that wall, and it would just mess this entire cave up. Ideally, a lot of our blast energy would have went up. That's the reason why when you look at a nuclear blast in old videos, that they have that mushroom cloud is because... Oh, my frame rate just died on me. The reason I have the mushroom cloud is because a lot of the energy gets pushed straight up into the sky because as you go higher up in the atmosphere, you get less and less... Why do we... Why did the... Is there some special code here that just ran and killed all the fire off? Maybe. I always have the theory that Minecraft's got hidden code in there to get rid of fire. But as I was saying, the reason why you see mushroom clouds form, and this happens with any large explosion, is because as you get higher up in the atmosphere, the amount of pressure gets less and less. And when an explosion goes off, it forces a lot of energy straight up, which then gets up in the higher pressure area, which then sucks more material up with it in a spiral-like motion, similar to a tornado, but not as quickly because a tornado is going to spin really, really quickly. An explosion spins really slow. It produces that mushroom-style cloud as it goes up. Volcanoes can produce the same style of cloud. There's actually a lot of stuff if you Google it. And we got a really weird line of fire just going like... Okay. But that works, I guess. We're definitely going to have to reduce the amount of particles we get. So we want to change this behavior. What I'm going to do is I'm going to go recode the actual thing that does the shrapnel. So we get a fragment of vent handler, and this spawns a fragment per thing. So what we want to do is we want to get the size of the explosion. So we do have access to the blast. The blast should give me my yield, or at least it should. It's actually not. We can set the yield, set cost, set energy per block, set additional block data. So I need to get yield. And if I go into blast here, I want to see if there is a get yield. Okay, so yeah, we just want to make sure this is actually part of the interface here. Surprised it wasn't already. Probably some hindsight here, where I was like, you know, it's not needed right now. Yield is about the same size or basically the same as the size. Unfortunately, it's how we're using it. We need to probably rename these because it is directly used as a size. So what I probably should change it to is get radius of blast, because then we might want to come in later and we want to go, okay, you're like a 10 megaton yield blast, and then from that 10 megatons we calculate the radius. But we want to go and we're going to go if event.blast.get yield is greater than 10. We want to start randomizing it. So we want to say every other block, basically. Not quite every other block, because we have a certain amount. What is volumetric amount of blocks we've removed here? I know it's way over a few thousand here. Let me look up the volume equation. I'm pretty sure it's like pi r cubed divided by something. It's like, I think it's 4.3. Yeah, it's 4.3 pi r. Yeah, it's pretty close. So radius of our detonation from there to I'm going to say 20. So 20. So yeah, we can easily do basically. I'm gonna round that up to about 34,000 because this is not going to be a perfect 20. So that's 34,000 blocks, and we want to have. We really only want to have a couple hundred particles in the air at a time. Blast fragment, spawn fragment. The reason I'm fixing this, even though we're probably going to still fake the particles, is this is a problem that if I scaled TNT up, that you're basically creating a lag machine that somebody could just rain fragmentation on top of something, and we kind of want to cut down on the number of fragments. So we want to randomize it, and then on top of it, we want to go if we're going to get the chunk basically. Chunk equals event dot. Okay, I need to see what we got available for location data. Maybe we just got X, Y, and Z. Get chunk from block coordinates. This will be event.x, event.z. Hopefully this is block coordinates. Yeah, okay, that converts over. We want to get the number of entities in the chunk. We want to go, okay, if chunk.entities, entity lists. Oh, wow, shoot. There's going to be no easy way for this to do this. Okay. So I'm going to make a method for this. Protected int number of fragments. So I might as well calculate the exact number of fragments, not just entities. And we'll pass in chunk as our variable. And we want to go if number of fragments chunk is less than, let's limit ourselves to 300 fragments. So that way there's no more than that per chunk, which is still a high amount when you think about it. Actually, you know, let's drop it to 100. This will prevent latency. Because the fragments are meant to be extra damage, they're not actually that lethal. Mostly they'll break glass. We will do an else statement here. To do Q for spawn or simulate or sim damage. How we would simulate damage, by the way, is we would do a ray trace that would follow the expected curve of that fragment, and then we would do damage that way. This is to kind of reduce lag, of course. We return 0. What we're going to do is we're going to go int fragments. Actually, we can just return fragments if we have a variable like that. And we're going to go for list chunk dot entity list. This is a really quick equation here, so a really quick algorithm, so it's not, we don't have to worry about it too much. I'm gonna go if object instance of, I don't want to do blast fragments. What is the actual entity called? Entity fragment. There we go. That'll give me the number of fragments, so that way I can cut down on that. And then additionally, we want to reduce the number of fragments we put up into the air. So what we're actually going to do is we're going to change this to if less than a certain size. We're actually going to do, yeah, 10 will be fine. Anything larger than this is where we want to start doing our randomization. So we want to go world, or that's not what I wanted. So be event.world.ran.next float is greater than, and we want to figure out some kind of value. So the larger our explosion gets, the less number of fragments we want, because theoretically how this would work is that really large explosions are just going to flat out turn the material into dust. So that's going to be created as your dust cloud, which we will implement here later, but you will not have as many shrapnel particles. So we want to cut down on the number of shrapnel particles, because of course this is the main reason to do this is to save on latency, but of course it's also somewhat realistic at the same time. So we're going to go, I'm not exactly sure how to do this. Because this is going to give us a value between 0 and 1, which means our output needs to be underneath 1, of course. And we want something like 0.5 times we want some kind of logomatic number. We could do the log of the size, maybe. This is where I should have paid more attention in algebra class. Or calc. No, we can't use calculus for this. Calculus would be kind of cool to calculate the amount of energy we need, but it's not going to help us here. Yeah, I need algebra. But mainly logarithms. I never really studied those too much. Because what I want is the size goes up, I want this value to go down. I also want a minimum value, so we're going to go math.max. So we want 0.1 is our lowest probability. Actually, we want this to be 9. So we want to have, like, lowest that we can get is you have a 10% success rate. And then we wanted to calculate some kind of value. And we want this to be at least 0.1 plus some kind of scale value. We can do yield divided by some large number would get us close. It's not going to be perfect. We'll say 100. A lot of the explosions are not over 100 in size. So this would create a really small number, so that way, actually we're going to increase this to 0.3. To do improve calculation to scale better with volume. Because right now this is scaling with size, which is not going to give us a really good result. This is the reason why this is going to be crap, and I'm going to have to come back here and redo it. What we want to do is scale with volume, because as you go up one radius, you can easily add 20,000 blocks to your volume. That's if you're at like 100. So the difference between 100 and 101 is actually a huge amount. This is the reason why I need a logarithm type equation to handle this. Anyways, we'll go ahead and restart Minecraft so we can test this and see if we end up with a lot better result. By default, this chunk limit here is going to save us. It's going to prevent too many fragments per chunk. It's probably going to end up with there being roughly 1,000 fragments still, so it's still going to have a pretty hard impact on our frame rate. But then hopefully the randomizer right there is going to take care of the rest of that. And if it becomes even more of a problem, what I'll do is I'll probably increase the velocity of the fragments so that way they die quicker. Because if I can get them going through the air a lot faster, it'll work out. And I'm probably just going to have to simulate a lot of the damage too. So rather than trying to be realistic, because the fragments they're not just for visual pleasing effects, because they're partially, that's the reason why they're made. They're also to try to give a really nice, realistic handling of fragmentation. So that way, if I hit a block, it realistically hit the block, you can watch hit the block, and then when I hit it, then that block can handle its own damage if it wants to. So I don't have to force behavior. I don't have to go, okay, your material is made out of glass, so I expect you to break. Well, you could be made out of glass and then have a ridiculous hardness value, or you could be protected by a force field or some kind of magic warding effect, and I don't know how you want to handle that. So there's a lot of weird things like that I have to deal with. I never closed that. Still got weasels. By the way, let me show you what I was talking about volume. See how it sets like 10 to the 6? Change that to 1. You add basically 20 times to 6. You add, I want to say, 20 million blocks just by going up 1 meter in radius. Though I think the highest radius we're going to have for a while is going to be that. But look at that. Look how many blocks that's going to be for a 45 meter radius explosion. The largest explosion that I do have planned, and this is actually going to be planned, is 1 kilometer. That's going to be the biggest explosion in the game. At least in the next year. We do plan to do a 10 kilometer explosion as the largest nuclear weapon. And then everything beyond 10 kilometers is going to be planetary style killing weapons. They're going to be so large that you're going to build one and you're probably never going to use it because it's going to flat out just wipe a planet out. Those are going to be things that I don't even know if we're going to implement. I'm going to have to find a couple developers to help me implement things like that. Not because it's actually hard. I can actually kill a planet without much of a problem in Minecraft. It's really easy to do. But what I want to do is balance it. I want to make it incredibly hard to make. So the bigger you get explosion-wise, I mean, for example, which by the way, you won't be able to craft a micro and a small warhead for nukes. The first size is going to be a standard. But even if I was allowed to craft this, or you were allowed to craft it in game, it would take you a day to make enough fuel to make it small. It would take you, I don't know, maybe an hour to make enough for a small. So that's for this crater right here. That's an hour worth of fuel production, not just the resource to go in it. So you include mining, energy, automation, all that stuff. You would need a factory probably about this big just to produce enough fuel for 1 warhead. Now your standard, take that same size factory, is going to take a day. Although of course we're talking Minecraft here, you could just make a massive factory that would take up that whole area. Anyways, fragmentation time. And this will be the end of the video as soon as we get this tested. Oh, look at that. Much nice lighter. Not as bad. We still get our fragment shower. I'm going to have to work on the distributions because, of course, you notice we're not getting anything over here. And we're not seeing a lot. We're just seeing stuff go from here to there to here. I just got hit by the radiation. The radiation is messing those guys up. but we're doing well. I would say a couple more weeks and the nuke will be ready for release. Um, I'll probably sneak the red matter in here pretty soon too. I'm gonna probably just copy the code from Classic for the red matter because I don't need anything special. How the red matter works in Classic is about the same as I'm gonna code it in ICBM. The only difference would be that between the two. Actually, let me rephrase this. What I'm probably gonna do is I'm probably gonna recode the ICBM red matter for in the Classic version. Then I'm going to migrate that code to a dependency that will then be downloaded by both Classic and ICBM, or shipped inside of both. I still haven't figured out how we're going to do that. I want to try to make the explosions in both of those mods identical to each other, so that way, even if you're using the classic version, it behaves almost identically to the new version. Um, Hopefully, you guys don't get too upset about that. But that's the end of the video here. I will hopefully make another video today. Unfortunately, I do have to go somewhere and do a couple hours of work, and then I've got to read about 200 pages of books here later tonight. I hate my class assignments sometimes. I got 4 books I got to read. Actually, let me phrase this. I got to read about 100 pages each of them, but I'm thinking about skipping 2 of them. That's where I got the number 200 from, because I don't really want to read the software engineering book, and I really don't want to read the how to run a software team book, because both of those I pretty much know already. The only one I'm probably going to read is the UML application and pattern book real quick. I'm going to skim it, and then I got a IT security book I got to read, which that one I actually want to master to prevent hackers from screwing with the mods. Anyways, I'll see you guys next time with more content.